Alright, so this podcast has to do with volume to volume stoichiometry, and this happens when we do titrations. It's very similar to mass. We're going to kind of set it up like this. Volume of A goes to mole of A, and from mole of A we can get a mole of B, and from mole of B we can go to volume of B. Alright, and similarly, in all stoichiometry problems, there's always a mole of A to mole of B portion, and that makes it stoichiometry. So for this part, we use the mole ratio. And what's different about volume to volume, as opposed to mass, is to go from volume to mole. Instead of using the molar mass, because that tells us mass to mole, the unit in chemistry that relates moles to volume is molarity. Alright, so we're going to use molarity here, and we're also going to use molarity in our last step. So like I said, it's very similar to mass, but instead of using molar masses, we're using molarities in their place. Alright, and we still use mole ratio in the middle. Alright, so I'm going to just give you an equation, and let's say we're going to react, let's say hydrochloric acid reacts with barium hydroxide. And this is going to form barium chloride, and it's also going to form water. And you might remember, whenever we mix an acid and a base, we always get a salt in water, and a salt is simply an ionic compound when it comes to chemistry. Alright, so as we balance this, put our lines up front, let's see, we have 1 Cl on the left, we have 2 Cl's on the right, so I'm going to put a 2 in front of HCl. Because we have H's everywhere, so we have 1 barium, we have 2 H's plus another 2 H's, so 4. So here's our balanced equation. So a 2 to 1 to 1 to 2 ratio. And the way these problems are always going to look is, you're going to be given molarity of 2 things and the volume of 1 thing. You're going to have to figure out the volume of the second thing. Alright, so here's the way a question might be asked. How many liters of, and I just need to make up a concentration, so let's say 0.250 molar acid, really we're talking about hydrochloric acid, are required and whenever we mix an acid base we call it neutralize. So how many liters of 2.5 molar acid are required to neutralize let's see, we're going to make up a number, 200 milliliters of let's say 0.15 molar base, and base is our barium hydroxide. Alright, so notice we're given 2 molarities, and I'm going to circle those in blue. So our 2 molarities are 0.2 molar acid and 0.15 molar base, and we're given 1 volume, right? And our volume is the volume of our base. So we're going to start with what we know the volume and molarity of together. Alright, so in that case we're going to be starting with our base. And notice if we look back up at our equation, we always start with volume of A. Alright, so we're going to start with 200 milliliters. But if I'm using molarity, that volume always has to be in liters. Alright, and how do we go from milliliters to liters? We always divide by 1,000. Alright, so I'm going to start my fence and rail kind of like this. 0.200 liters. I'm going to write barium hydroxide. I want to write my unit because it's going to guide me. So don't not write your units. Alright, and we're going to do a fence and rail, so we kind of long. And our next step, we let our units be our guide. If we have liters on top, we need liters of barium hydroxide on bottom. And in this first step, we want to go from volume, or liters, to moles. So I'm going to put moles of barium hydroxide on top. And if we have moles over liters, notice our fence is moles over liters, what is that known as? That is simply known as molarity. So we're going to come back up to our equation and find what is the molarity of our base, and it's 0.15 molar, and that means 0.15 moles per liter. So I'm going to go ahead and put 150 moles per 1 liter. Okay, it's understood to be 1 if we just say moles per liter. Just like miles per hour is how many miles you go in 1 hour. Alright, so I have effectively changed the liters to moles. The next step is I want to go from moles of A to moles of B. And how do we do that? We use the mole ratio. So again, I'm going to let my units be my guide. And in this case, I want to write moles of barium hydroxide in the denominator. And I want to change this to moles of hydrofluoric acid. So this is what makes it stoichiometry, because we're using a mole ratio. And our mole ratio is 2 moles of HCl equal 1 mole of barium hydroxide. How do we know that? We get it from our equation, and just these two numbers right up here on our reactant side. Alright? So now we've gone from liters of barium hydroxide to moles of barium hydroxide. Now from moles of barium hydroxide to moles of hydrofluoric acid. So the last thing we want to do is go from moles of B, which is what we're looking for, to volume of B. Alright, and how do we do that? We use molarity again, even though you can't read molarity right there. Alright, so if we let our units be our guide, notice we're going to have moles of HCl in the denominator. And in the numerator, we're going to have liters of HCl. And again, in this fence post, I have moles and liters. Alright, if I have moles and liters, that is what molarity is. So my molarity of my acid are 0.25 molar, which means 0.25 moles per liter. Alright, so my 0.25 is not going to go on the denominator because it goes in front of moles, and that's moles per 1 liter. Alright, so now we're going to multiply across the top, multiply across the bottom, and simplify. Alright, so I'm going to pull up my calculator, and across the top I'm going to do 0.2 times 0.15 times 2, and really times 1, but we're not going to worry about the times 1, so I have 0.06 is my value on the top as I multiply across the top. .06. And on the bottom I still have 0.25. Let's look at units. Alright? And notice in my first fence post I have liters of barium hydroxide, and that's going to cancel out with liters of barium hydroxide in the second fence post. I have moles of barium hydroxide, which is going to cancel out with moles of barium hydroxide. I have moles of HCl, which is going to cancel moles of HCl. I'm left with liters of HCl. So my unit that's left is liters of HCl. So all that's really required is I just need to simplify that fraction. 0.06 divided by 0.25, and I get 0.24. So our final answer is 0.24 liters of HCl, which is the same as, or is equal to, 240 milliliters, which is kind of what we'd use in class. But the question, if we go back to the question, it says how many liters? So really I would leave my answer as 0.24 liters of HCl. And that is volume to volume stoichiometry. That's what we'll be using when we do some titrations in class.